To show the framework from the abstract view, if we have an open source project that will be given as an input to the proposed framework, then the output will show the degree of the goodness, the degree of the badness, and how much it is regular. It shows the quality levels as a fuzzy information. It is fully automated framework for software quality assessment. If we go one level deeper inside this black box, then we can discuss more details about the framework. There are many quality attributes such as maintainability, stability, and usability. In our work, we focus on maintainability. However, the framework is applicable to measure the quality of other attributes. We select a set of software metrics that are useful to measure maintainability. Again, the framework is flexible to use any other metrics. To use the software matrix for quality assessment, we need a threshold for each matrix to help us judge what is good and what is bad. Till now, nothing new. If an entity is evaluated by the framework, then we expect that the framework can calculate the required matrix and apply the threshold to judge what is good and what is bad. In the output, we can observe that the degree of the badness is twice the degree of the goodness. This is because there are two matrices that are denoted as a bad quality and one matrix that is denoted as a good quality. Is this accurate assessment? Are all matrices have the same impact on the overall quality assessment? What about if the impact of the first matrix is higher than other matrices? In this case, it is better to have a weight for each label in each matrix to show the impact for measuring the overall quality. We may need a table like this. Using the weights, we can see more realistic judgment. We can notice that the total sum of the weights for all bad quality labels is 0.19 and the weight for the good quality label is 0.21. This is an overview. Now let us go more deeper to discuss some details. The first step, the open source project that we need to assess will be given as an input. Let us go inside to see what happened in action. In the first step, the open source project that contains 10 classes or entities will be analyzed by a software tool called CKGM to calculate the software matrix. The output will look like this. Each row belongs to each entity, each column belongs to one software matrix, and the intersection shows the measurement value of the entity in the metric. Before we move to the second step, I would like to emphasize about one thing. The framework is not restricted on using this tool. Any other tools are applicable. One restriction is that if we use any other tools to calculate the software matrix, then we need to make sure that we use the same tools during the process of identifying the thresholds. In the second step, we will use the table on the right side to convert the extracted values into three levels of quality. The table on the right side contains matrix thresholds, where each matrix has two thresholds to identify three levels of quality, which are good quality level, bad quality level, and regular quality level. The measurement value in the intersection between the first entity and the first matrix can be converted as follows. The value is in the range of the good quality label. We will do this for the next value and the third till we replace all values with its corresponding quality label. Before we move to the third step, I would like to emphasize to one point. The threshold shown in the table on the right side can be extracted by any other methods. The idea of the framework is not to show how thresholds can be extracted, but it shows how can we use them for quality assessment. In the third step, we will use the table on the right side to calculate the class level quality. The table contains the weights that shows the impact of each label in each metric. It can be used as follows. For the first class, We will identify the weights of each quality metric label. We will use the equation below to calculate the degree of the goodness. In the denominator, we will calculate the total sum of all identified weights. The goodness degree is calculated by summing the good quality weights normalized by the total sum. We will do the same process to measure the degree of regular quality level, also the degree of bad quality level. We will do the same process for all other classes. Before we move to the fourth step, I would like to emphasize to one point. The weights shown in the table on the right side can be extracted by any other weighting schema. The idea of the framework is not to show how the weight can be extracted, but it shows how can we use them for quality assessment. In step 4, we will use the intermediate result to calculate the project quality level. The denominator will be the total sum, which is equal to the number of all classes. In our example, the total sum is 10. To calculate the degree of the goodness of the whole project, we sum all the values in the column of the degree good normalized by the total sum. We will do the same process to measure the degree of regular quality level and also the degree of bad quality level. The result can be summarized as shown in this figure. This is an overview of the proposed method. In the future, based on the intermediate result of the proposed method, we can build bad smell detection system, refactoring recommender system, maintainability analysis system.